but will never, ever, ever intersect. Or they never touch. In order for lines to never intersect, they have to have the same slope. So when you're given equations of parallel lines, they will always have the same slope. The slope will always be the same. Okay? So if we look at some examples, we want to determine if these sets of lines are parallel to each other. We'll first identify the slope. Okay? What's the slope of this first line? 1/3. So the number in front of the x, that's your slope. What's the slope of the second line? Negative 1/3. Are the slopes exactly the same?
No.
No. So are these parallel?
Nope.
No. Not parallel. And I like to abbreviate parallel with my symbol. Not parallel. If you want to write out the word, not parallel, or you need to do that. How you could have figured this out using Desmos. Okay, if you forget, you're like, I know lines that are parallel are never going to intersect, but I forget the fact about their slope. What you can do, because I think just looking at the slope is a lot quicker, but what you can do using Desmos is just plug those lines into Desmos. So you could have just plugged in y. You have to put y equals 1 divided by 3 x minus 7. And then you plug in negative 1/3 x plus 15. Are those lines parallel? No, they intersect, right? So it's another way you can figure out the right answer. You forget the rule about the slope of parallel lines. Plug it into Desmos. Or if you want to check your answer, plug it into Desmos, and you'll see whether or not you're right, whether or not they touch or not. I personally think it's a little bit quicker just to look at their slope, but if you forget, this is a backup. Oh, I guess you don't have to put. I thought you did. You don't have to. I thought you had to. That was particular, actually. I think. Questions over that? If we take a look at the next one. We take a look at the next one. What's the slope of my first line?
2x.
2. No x there. What's the slope of my second line? 2. What can we say about these lines?
Parallel.
Parallel. Their slopes are exactly the same. They're both the same sign, same number. How you could have used Desmos. Plug it in. Plug in both lines. Y equals 2x minus 11. And this was y equals 2x plus 5. I guess you don't have to put the y equals. I have it. Do these look parallel? You might have to scroll up a bunch and scroll down just to be sure. But do these intersect? No, these are parallel lines. They never intersect. Okay? So that's how else you could have gotten the answer. Okay? Questions over that? Let's take a look at some more examples. What's the slope of this first line?
1/2.
1/2. How can we figure out the slope of this line?
Solve it.
We have to solve for y, right? We have to get in y equals mx plus b fourth. How are we going to solve for y? Subtract 3x. Move the 3x over. And then we can't combine the x and the 3, so we just stick it right out in front. And then we add on the 18. Okay? What do we have to do with the 6 to get y by itself? Divide. So we get y is equal to, and you have to simplify fractions or you won't be able to tell. What's negative 3 over 6? What does that simplify down to?
1/2.
Negative 1/2. What does 18 over 6 simplify down to?
3.
Okay. So now that we solve for y, what's the slope of this line? It's not parallel because the slope is negative 1/2. They don't match perfectly, so they are not parallel. What if you're like, oh no? Right? forget how to solve for y. Or I want to solve for y, but I'm going to make a mistake. I'm nervous I'm going to make a mistake. What you can do is literally plug it into Desmos exactly how they're written. You don't need to solve for anything. You can do y equals, or was I? See, 1/2 x minus 5. And then plug it in. You don't have to solve for anything. You just put 3x plus 6y equals 18. Are they parallel?
No.
No. So you could have also just done that and gotten whether or not they were parallel because they intersect. Okay. Questions over that? Try those next two on your own.
But, okay.
So take a look at D. What did we get to D? What did we determine? What's the slope of this first one?
4/5.
4/5. What's the slope of the second line? 4/5. Yeah, these are a little different because it's in point slope form. But the slope is just right in front of the parentheses. It's still technically the number in front of the x. What can we say about these lines? Parallel. Parallel. Slopes are the same. What's the slope of the second line? -7. Number in front of the x. What's the slope of this other line? 7. What can we say about these lines? They're not parallel. So again, it's a little quicker not to have to plug it into Desmos. But if you forget, plug it into Desmos and it will tell you whether or not. Questions over that? If we take a look at the next one. Which of the following lines is parallel to the line y equals 2/3 x minus 1? Before there was this Desmos calculator online, what we would have to do is solve each four of those equations for for y, and see which one had the same slope. Which you really need to do all that work.
No.
What can you just do? Plug it into Desmos. Okay, so plug the original equation in. Y equals 2/3 x minus 1. Y equals 2/3 x minus 1. And then just plug each option in and see which one ends up being parallel. So let's plug in A. 2x plus 3y equals 12. Are they parallel? Nope, not my answer. So let's plug in B. 4x minus 6y. Nope. Oh, I did that first period. Sorry. That was okay. Thank you. 4x minus 6y. Are these guys parallel?
Yep.
Yeah, you might need to scroll a little bit because they might intersect really low or really high, but just double check. Those are never intersecting. Those are my parallel lines. So it's a lot quicker and a lot less work sometimes if you use that. Especially those multiple choice types of questions. This is the concept of parallel and perpendicular lines is a big OST concept. If they were to ask this type of question, it would probably be like this. Okay. So again, you can use Desmos. It will save you some time and some thinking on that test. Okay. Questions over that? Perpendicular lines are a little different. Perpendicular lines, if you remember, are lines that intersect and form what type of angles? They form right angles. Okay. For that to happen in the coordinate plane, perpendicular lines have to have opposite reciprocal slopes. What that means is opposite means they're opposite signs. One's positive, one's negative. Reciprocal means they're flipped versions of each other, or an upside down version of each other. Okay? So if we take a look at an example, the opposite reciprocal of 4/5 is negative 5/4. They're opposite signs, one's positive, one's negative, and if we flip 4/5, we get 5/4. And that means that's what makes it an opposite reciprocal. Alright, so parallel line slopes are exactly the same. Perpendicular lines are opposite reciprocal slopes. Flipped versions, opposite signs. We look at some examples of just figuring out the opposite reciprocal. What's the opposite reciprocal of 3/2? Positive 2/3. They're opposite signs. One's negative, the other one's positive. If we flip 3/2, becomes 2/3. The 3 goes in the bottom and then the 2 goes in the top. Okay. When we have a whole number, I think it's helpful. Make it into a fraction. What do we put all whole numbers over? 1. So what's the opposite reciprocal of 5/1? Yeah, negative 1/5. We make it the opposite sign, and then we just flip that fraction. What about the opposite reciprocal of negative 1/3? Positive 3. We flip the 1/3, becomes 3/1. If you leave it as 3/1, I would still accept that as being fine. But technically 3/1 is 3. The original is negative, so my opposite reciprocal needs to be positive. And then the opposite reciprocal of -1, again, we have a whole number, so we're going to put it over 1. When we flip 1/1, it becomes what? 1/1, right? The original is negative, so my opposite reciprocal is positive. So the opposite reciprocal of -1 is +1, and vice versa. Questions over that? So that's what you're looking for, opposite reciprocals, when we're dealing with perpendicular lines. I think it's hard to use Desmos for perpendicular lines. It doesn't tell you if it's a right angle. You have to kind of guess if it's a right angle. Sometimes it looks like a right angle and it's not, or it doesn't look like a right angle and it is. So I think it's trickier for perpendicular lines. But you can still plug it in and see if you can tell. Some of them are very distinct to whether or not it's perpendicular. Some of them are a little harder to tell. So again, you can use Desmos. I would do both. I would look for the opposite reciprocal, plug it in your Desmos just to check your answer. I think it's just perpendicular is a little bit harder to tell. But what's the slope of A? The first line in A. What's the slope of the second line? Negative 3/2. Are they and what I like to do is check first thing, are they opposite signs?
Yes.
Yes. That right away will tell you if they're perpendicular, or a step to tell you if it's perpendicular or not. So they're opposite. So then check the second thing. Are they reciprocals? Are they flipped versions of each other?
Yes.
Yep. So are they perpendicular? The slopes are opposite reciprocals, so they are perpendicular. Questions? I guess a way you can tell. Let me see if this works. We'll see. I'm going on the fly here. I guess one way you can tell. Let's plug it into Desmos. Might seem a little odd. I'm not gonna go. I'm gonna see if it works. I don't know. May or may not. That's the wrong piece of paper. So you can try this. We're gonna see if it works. I'm going on the fly here. It might not work, but bear with me. I just thought of it right now. How you can tell. 2/3 x minus 1, and then I'm gonna plug -3/2 x plus 7. Right. If you can line up your piece of paper and it fits perfectly in that corner, how the lines are going right with the corner of the paper, they're perpendicular. Right? Because your sides of your paper are perpendicular. So you can turn your paper and it fits right in that corner perfectly, like so, like I'm doing on the screen. Sorry if you're watching the video, you can't see it, but that's how you can tell that it's making a right angle. So you can probably put that piece of paper up on your screen in Desmos, and if it fits, it's a right angle, they're perpendicular. If the paper doesn't fit, not a right angle, not perpendicular. Does that make sense? I'm trying to think of what you're going to have on a test, and you'll have paper. So that's how you can use paper itself. It seems silly, but it's a way to do it. Okay? Questions over that? Yes? Yeah, you might have to, like, your paper can fit on your phone book. A little bit. Yeah, it's a small screen. Just kind of fold. You might have to, like, adjust your paper a little bit. It should fit. So the corner fits right in there nice. And it's a right angle. Okay. Questions over that? I'll show you an example where it's not a right angle. So we take a look at the next one. What is my slope of my first line? 1/5. What is the slope of my second line? Are they opposite signs?
No.
No. So are these perpendicular? No. They're reciprocals, but they're not opposite. They're both positive. So right away, I know it's not perpendicular. It has to fit for both things. It has to be opposite signs. They also have to be reciprocals. It has to be both. Okay? So when I plug this in to Desmos, I'll show an example of when it's not perpendicular and how it doesn't fit on your paper. Y equals 1/5. 1/5 x plus 3. And the other one is y equals 5x minus 6. So you see, if I try to get my paper in there, I can't. There's no way I can turn my paper to get it to fit. I can turn it there, but then the black line's not following the back of my paper. I can turn it here, but then the red line's not following that other side of my paper. There's no way I can fit my paper in between those two lines. Does that make sense? Okay. So that's one way you can check if you're not sure. Using Desmos. It might seem silly, but it's a way to get the right answer. Okay? What's my slope for the first one? -3. What would we have to do here if we didn't want to plug it into Desmos? Solve it. We're going to practice solving. Again, you can plug it into Desmos and use that paper trick, but we're going to do along here. I'm going to move my x over. So I get -3y equals, I stick that x in front. Well, if it's helpful, technically, what's in front of that x? A -1. And then what do we have to do with that -3? Divide. Divide everything by -3. So y is equal to, what's negative over negative?
Positive.
Positive 1/3. And 12 over -3 is -4, but we don't really care about the y. What is the slope of my line now? 1/3. Are they opposites?
Yes.
Are they reciprocals?
Yes.
Yep. Again, if it helps, put it over 1. We flip 3 over 1. We get 1/3. So are these perpendicular? Again, you could have plugged that into Desmos without having to solve and do the little paper trick. What's the slope of this line? The first one?
-2.
-2. What's the slope of the second one?
1/2.
Are these lines perpendicular? Yes. They're opposite. Negative, positive. And again, whole numbers, if you put it over 1 and flip it, 2 over 1 becomes 1/2. Oh, yes. What about E? What's the slope of the first line? 5/2. What's the slope of the second line? 5/2. Are these perpendicular? No, they're actually what? Parallel. Okay. So they're not perpendicular. They're actually parallel. Questions over that? We take a look at the last one. It says the slope of side RQ, this purple side, is 3 over 4. We want to find the slope of this green side, RS. Well, here's the thing. We can't do rise over run because we aren't given grid lines and we aren't given coordinates. We don't really know where these points are in the coordinate plane. It's just kind of floating there. But they gave us that one side RQ is 3/4. What do you notice? What type of angles do those two sides make? Makes a right angle, which makes them what? Perpendicular. And what do we know about the slopes of perpendicular lines? Opposite reciprocal. So if the slope of RQ is 3/4, the slope of RS is going to be that opposite reciprocal. So what is the opposite reciprocal of 3 over 4? Negative 4/3. Again, you just flip the fraction and then change the sign. So that is the slope of RS. Let's say, just for fun, RQ and SP are parallel. So if RQ is 3/4, what's the slope of SP? 3/4. Parallel lines have the same slope. Questions over that? No? Okay.